The sum of two n-bit binary numbers can be represented by a n plus 1 bit binary number. The sum of two n-bit binary numbers can be too big to be represented by n bits. In this case, it is considered an overflow. A full adder is a device that adds three binary bits of equal weight and the same sign. The result is represented by two bits, sum and the carryout. If the sum is of weight 2 to the n, carryout is of the 2 to the n plus 1 weight. Using full adders to add two binary numbers represented in 2's complement format using carryout, the correct sum is produced only sometime. Let's look at an example. Now remember, we are representing the output, the sum, the result in 5 bits. See, this is a 4-bit number. So -8, -8, and the result is -16. So let's look at another example. Remember again that we are representing the result in 5 bits. 1, 2, 3, 4, 5. So we add 7 plus 7, and then the result is 14. 8 plus 4 plus 2. So we look at these results, and based on this, we might be tempted to think the results will always be correct if we consider carryout as the most significant bit. But this is not the case as shown in the example below. Suppose we take -8 and plus 1, and then using the full adders we get this result 0, 1, 0, 0, 1. Remember again, we are representing the result in 5 bits. So in this case, the result is 9. But if we represent this number in 5 bits, in 4 bits, then what will happen? This bit here will become -8, and then this 1, and then the result will be -7. So if we represent the number in 4 bits, we get the correct result. But if we represent the number in 5 bits, we get the wrong answer. 5-bit representation gives the wrong result. So this approach is not correct. We have to make up our mind whether to use n or n plus 1 bits to represent the result. If we use the n plus 1 representation, we need to use a special adder that adds 2 negative bits and 1 positive. Because here the carry coming in to this position will be positive and these 2 bits are negative. So this here will be 0, 0. In this case, it will be 1 and 0. And this case will be 1 and 1. Because carryout has a weight of -2. So this is -1. So based on this, we fill up this table. And then based on this adder, let's add the same number. The one gave us the wrong result before when we used the regular full adders. So here we have 1 and 0. So that will be this case here. So we will have 1 and 1. We have 1 and 1. So what we have is minus 16 plus 8 plus 1. The result is minus 7. But this is not the regular full adder. This is the special adder. So if we are going to represent the result in 5 bits, that's n plus 1 bit, we have to use this special adder for right here. But if we're going to use the full adders, then what we have to do, we have to represent this number here in only 4 bits, and then this becomes negative. So that's about it.